now we have stored our face data. What I'm going to do is I'm going to detect my face again. Okay, I'm going to not detect my face again, I'm going to recognize my face using KNN. So I'm going to import CV2, I'm going to import numpy as SNP, I'm also going to import OS. So let's take cap equal to CV2 dot video capture, and in this I need to pass 0. Also I'm gonna need this, and also I'm also going to need this. Okay, so we have this. What I'm going to do is now I'm going to take face data equal to a list, then I'm going to take labels equal to list, and I'm going to take names as a dictionary. I'm going to tell you what I'm doing here right now in just a minute. So the class ID is going to be 0, class underscore ID is going to be 0, and then face section is going to be np.zeros, and in this I need to pass 100 by 100 again, because our face size is 100 by 100, so that's why I'm doing it. Okay, D type is U8. Okay, so now what I'm going to do, for file in os dot list dir, and I'm gonna go give this path. So what I am doing here, basically, let's suppose, okay, so let's suppose we have my face here. It might contain some other file as well. Let's suppose there is a boy Ramesh, then his file is also going to be here. Okay, so that's why I'm getting all the files. So what I'm doing here, I'm using the os.list directory to get the name of all the files. Okay, now what I'm doing is, if file dot ends with, so if the file is ending with .npy, then what we are going to do is to get those files. Okay, so data item is going to be np.load directory path plus file. Okay, so what I'm doing here is that I am loading the image, or loading the first file. Basically, I have only one file here, which is gagan.npy, so I am loading that file here. Okay, now the next thing is, yeah, so now what I'm going to do is I'm going to make a dictionary name, or let's take name, let's make this names, and in this names I'm going to make the first class as class 0, and I'm going to store that file name here. So file name should be -4. Okay, let me explain you what I'm doing here. We have loaded a file with this line, and we are checking whether the file is a npy file or not with this line, and we are traversing through all the files using this for loop. Okay, so what I have done is I have loaded the file. Let's suppose the file name is uh, gagan.npy. So what it is going to do, it is going to make a list, and right now class ID is 0. So what it is going to do, it is going to make a dictionary in which 0 is going to represent Gagan. It means that 0 class name has Gagan. Okay, and we are removing this part with this line or with this slicing. Okay, so this is what we have done till now. Okay, so the next thing is we want to append that face data equal to append data item. So if you might remember that what we did in the last video, we had something like this, the number of faces. So let's suppose in my case, in my specific case, I stored 50 images. Okay, so and as we were saving our data with the shape of 100 by 100, so that was 10,000, so its shape should be 50 times 10,000. So what I am doing is I am appending all of this data into a list, so it is going to be a 3D matrix again. Okay, and it's data append. Okay, so let's do print. Not we do not have to print anything. So what I'm going to do is target. I will tell you what it is. Target equal to class underscore id time np dot once data underscore item dot shape 0 and this. Yeah, so I will just explain you in a minute. Class id is going to be implemented now 1 and labels is going to append target. Okay, so what we are doing here, let's suppose we had a list like this. Okay, we have a list like this. We got the name. In the first file, which was my file, so the shape of that file was 50 times 10,000. Okay, so what it is saying that I have 50 images of myself, or I have 50 images of a single name. The second user might have only 10 images. The third user might have, let's say, 2 images, and 10,000 is going to be same in every case. In this case also. So this is true. Yeah. So user could have stored any number of images. It is up to him. So that's why it can be different. Okay. So what I am doing here is that I am making a vector of ones. So what it is going to do, the shape is going to be this data item dot shape, and data item is this array. So our array shape is 50 times 100. So I have taken the 0th element here. So our shape is going to be 50. And what we are going to have is, we are going to have a column of ones whose shape is going to be 50. And now what I am doing is that, as this is the first image, so what I am doing is I am making this as a class name. So this is going to be 0 class, as we have multiplied it by class id. Now right now it is 0, so it is going to be 0. Let's suppose now we move on to the next part, and now class id is incremented. So we have this. Now what I'm going to do is I am going to multiply this by 1, so again it is going to be 1. Now in this part we will have 1, and right now class id is 2, so this is going to multiply by 2. So what it is going to do, it is going to append all of them into a label. So what it is going to do is like this. Let's suppose 0 0 0 0 0 0 1 1 1 2 2. So it is going to make something like this, and you can see that, like, okay, so this 0 is supposed to the first example here, this 0 is supposed to the first example, first second image, this 0 belongs to the first example, third image, and similarly, like now, then it is going to match with these, and then this 0 is going to match with them. or this 2 is going to mess with them. So this is how it is working. Now you should know how KNN work for this to understand well. Uh, so let me just give you an explanation again. Okay, so in KNN what we do is that, let's suppose we have some data. Okay, and this is our data. Then we have some other data. So let's suppose we have three faces. Okay, we have faces of Gagan, we have faces of Ramesh, we have faces of Akash. Okay, so let's make, suppose this is Gagan, this is Ramesh, this is Akash. So what we want to do is we want to predict which face is this. Okay, so what it is going to do, it is going to detect the distances, and as you can see here, it is closer to Gagan. So it is, how it is going to know that it is closer to Gagan, because it has a y value, and when it has a y value, so what it is going to do, it knows that okay, it has a y value. So that's what we were doing here, that what we did is, for every image we set, okay, whether this is this belongs to class 0, this belongs to class 0, okay, this belongs to class 2, this belongs to class 1. This is what we have done here. Okay, now let me just rub it. Okay, so this is complete. Now what I have to do is face data set, and it should be face data dot append. Okay, so I'm going to make the data set here right now, and it is going to be np dot concatenate labels comma axis equal to 0, and I'm going to make it reshape to -1 comma 1. So what it is doing now, we have a list. You can say that we have a list. In this we have multiple 2D arrays. So it has, let's say, 550 times 10,000. It has, let's say, 20 times 10,000. Okay, so as you can see here, this is a 2D matrix. Then if we will consider this, then this is a 3D matrix. But we do not want it to be a 3D matrix, because there is no need for us to make them in a separate file. So what I am going to do here, I am going to concatenate on the basis of the rows, because we have provided the axis as 0. So what it is going to do, it is going to make it like this. So it will not be different anymore. So it is going to make it like this. Then it will have a shape of 70 times 10,000. So this is what we are doing here. Basically, you can say that we are converting this data from 3D to 2D, if you want a simple language for that. Okay, and we are gonna do the same thing for the face labels also. So face underscore labels is going to be np dot concatenate labels, and here I should give my face data, face underscore data. Okay, face labels, and here I should give x is equal to 0. Again, I am going to reshape it as -1 comma 1. Okay,